Okay, we have our another integral from the Unsw integration meet from 2024. This is problem 12. We have the integral from 0 to pi over 2 secant squared x over tan cubed x plus 2 tan x plus 2 cotangent x dx. Okay, to get started with this, I just want to kind of make a couple observations. Just the fact, like secant squared x is always interesting. So we've got secant squared x in the numerator, and we've got a tan x here. The derivative of tan x is secant squared x, so it's making me think u substitution. I'm not quite sure what's going to happen with cotangent x. I mean, this is going to be fine. If we make our u tan x, then this over here is going to be u cubed. So let's just go ahead with it and see where it goes. So we'll come over here and do this thing. So I'll say u is equal to tan x. I'll take a derivative, and du is going to be, again, just the numerator secant squared x dx. And actually, I was kind of lying earlier when I said I don't know what's going to happen to the cotangent x, because cotangent is just the reciprocal of tan x. So we can get our value for cotangent x. This is just going to be 1 over u. So we'll go ahead with this substitution over here. So first, let's look at pi over 2. When we have tan at pi over 2, this is going to infinity. And then when we plug in 0, tan at 0 is going to be just 0. And now again, the whole numerator is going to be just du. Here we have u cubed. We're going to have 2u right here, and this is going to become 2 times 1 over u. I'll write this as 2 over u. Now from here, what I'd like to do is factor this denominator somehow, but honestly, the problem is, how am I going to factor this with 2 over u? Well, we could do it, but I'm actually not that comfortable. Well, we still could probably factor this, but I'm going to feel more comfortable if I fix this here. So if I just multiply in by u, I'll multiply by u over u, so we're not changing, we're multiplying by 1, and then that's going to fix this thing here. So let's just rewrite and multiply everything in. So we're going to have this u du in the numerator. We'll multiply here u times u cubed. We're going to have u to the 4th plus 2u squared. And then here the u's are going to just cancel here, and we'll just have a plus 2. But now I can factor this here. What I can do is complete the square, and we can look at this. We can look at this first part as u squared plus 1 squared. You multiply that out, you're going to get u to the 4th plus middle terms give you u squared, or 2u squared plus 1. I want to get plus 2, so I just need to add a 1, so we can write this as u squared plus 1 squared plus 1. So we'll do a quick rewrite to see what we have. And now we're getting somewhere, but I still want to clean this up a little more. What I'd like to do is simplify this with another substitution. So what I can do for this is we'll use t. So we'll say t is going to be equal to u squared plus 1. And then we take a derivative here. So for our dt value, we're going to have just 2u du. Now we can get this exact value in the numerator if I just multiply by 2 here, and then we'll multiply by a half, so I'm not changing it. Now notice, because I've done 2 substitutions, we actually could have consolidated this, right? I could have done all one substitution. If u is tan x, I could have substituted here for t, tan squared plus 1, and actually tan squared plus 1 is secant squared. So you can see there's another way to do this where we could just factor it initially and then just done one substitution. Okay, now let's go ahead with this substitution right here. So we'll bring it down here. So first, let's update our bounds. So we plug infinity in for u, infinity squared plus 1, that's still infinity. And we plug 0 in here, we're going to just get 1. And again, all this stuff here, this is just going to be our dt value in the numerator. And then this denominator is just going to become t squared plus 1. But now we're in good shape, because this integral is just going to be arctan. So our value for this, we're just going to have arctan of t. And we just need to evaluate this from 1 to infinity. So we'll bring this 1/2 out front. Evaluating arctan at infinity, this is going to be pi over 2. And then arctan of 1, that's going to be just pi over 4. But what I can do here is let's just get a common denominator of 4. So what we have here is 2 pi over 4 minus pi over 4, or just pi over 4 times 1/2. So for my final solution for this, we're going to have just pi over 8. Okay, there you have it. Good integral from Unsw 2024. Thanks everyone for watching. Have a good day.